This video, we're gonna put absolutely everything we've done in quadratics except for the discriminant all together. So let's see. We have something called factored form, which we get the zeros, standard form where we can get the y-intercept, and vertex form where we can get the vertex and the axis of symmetry. So we know how to go from here to here. We expand it, or to go from standard to factor, we factor, and to go from standard to vertex, we complete this square. So if we have a parabola like this, the main points for that parabola are going to be the two zeros, the horizontal intercepts, the y-intercept or the vertical intercept, and the vertex. And with the vertex we have the axis of symmetry too. So two ways of finding both vertex and zeros. How do we find the vertex? Well, either we have the zeros. From the zeros we get the axis of symmetry by taking the average, and that gives us the x of the vertex, and then we plug it back in. So zeros, axis of symmetry, plug it back in, and that gives us the vertex. Or we complete the square, and from vertex form we can get the vertex. Two ways of getting the zeros. So I factor and solve. So when I get the two brackets, I put the little arrows and say as long as it's equal to 0, I got the bracket, this is equal to 2, this is equal to 5/2, whatever it is. And the other way is to use quadratic formula, which it's a big formula, but it gives us the two answers. We're going to get the same answer with both. Now, I'm probably going to use this version, zeros, axis of symmetry, plug it back in, when I already have the zeros, or it's easy to get them. If I can't get the zeros easily, I'm just going to complete the square. And for this, I'm going to try to factor first. If it looks like it can be factored, it's easy. I'll do that first. If not, I'll do quadratic formula. How do you get the y-intercept? Well, we know that we just plug with the variable equal to 0, and we spit out what the height's going to be. So f at 0 to find the y-intercept. So let's look at two examples. They're asking us to sketch h at x of minus 2x squared plus x plus 10. So I'm going to find the horizontal and vertical intercepts, the axis of symmetry, and the vertex. So the easiest one to find first is the y-intercept, because I just sub x equals 0. And if that's 0, that disappears, that's 0, all I'm left with is 10. 10. So I have my y-intercept. Great. Let's look at my x-intercepts, or my zeros. I say 0 equals to whatever they gave me. And now I'm going to try to factor it, see if it works. The first thing I'm going to do is I'm going to factor out that minus in front. And I take that minus and it becomes 2x squared minus x minus 10. So it's a complex trinomial. I can't take any more common factor. It starts with a 2. So it's not a perfect, it's not one of the special cases. So I'm going to use the box method. To get 2, I'm going to get 2x and x. I'm going to draw the cross. And I'm going to get 10. I can get 10 by 5 and 2, 2 and 5, 10 and 1, and 1 and 10. Immediately I can see that if I have a common factor, I can get rid of those cases. So the 2 and the 2 means that this goes away, this goes away. I'm just going to try this too. 2 times 2 is 4, 1 times 5 is a 5. With 4 and 5, can I make minus 1? Yes, I can, as long as it is minus 5 plus 4. So minus 5 plus the 4 that comes from here. So it's 2x minus 5 and x plus 2. And now that I have it in factored form, it's super easy to get the zeros. So from this one, x plus 2, I know that in order to make that go to 0, x needs to be negative 2. And from this one, I want this to be positive 5, but the 2 is bothering, so it's going to be 5/2 positive. And I know that 5/2 is 2.5. Okay, so we're going to start sketching. And I'm going to borrow this thing for a sec. And I have that my y-intercept is 10, and my intercept is minus 2. And 5/2, which is 2.5. So it looks like it's going to open up. Does it make sense? Well, it's a negative a value, so yes, it will open up. And that so far matches. Okay, so I got the y-intercept, the x-intercept. I'm going to look for axis of symmetry. Well, I got the two zeros, so I'm going to zeros, axis of symmetry, to get the x of the vertex. The axis of symmetry, I need to add the two zeros, so 2.5 plus minus 2. 2.5 plus minus 2 is just 0.5. 0.5 divided by 2 is equal to negative 0.25. Let's see if it makes sense with our diagram. Well, this is 2.5, this is minus 2. It's going to be a little bit on this side, but very close. Very close to the axis, probably a little bit more. So it's a sketch. We're going to be a little more forgiving. 0.25. But it made sense that it's on the positive side because that number is bigger than that number. Okay? So let's carry on. I know now that the x for the vertex is negative 0.25. So I can put it here, negative 0.25. And now I just need to find the y of the vertex. So I got zeros, axis symmetry. I'm going to plug it in, and I'm going to put the negative 0.25 inside here. So 2, my x squared, 0.25, and negative 0.25. And if we plug that onto our calculator, we're going to find out that the answer is 10.125. 10.125. And therefore the vertex here is 10.125 on the y and negative 0.25. Let's see if that makes sense in our diagram. Since this line is really close to the axis, it makes sense that it would be just a little bit bigger. 0.25 and 10.1. Is it 125? Yes. It makes sense that it's going to be so close to the y-axis. And it'd be something like that. Now in this case we chose to go with factoring and then doing zeros axis symmetry and plug it in. Let's see what it would be like to use the other two methods, because it's going to give us the same answer, but we do it with different examples. So if we need to sketch 0.15x squared plus 0.3x minus 1, okay, we need to find the same things, the y-intercepts, the x-intercepts, and the vertex with the axis of symmetry. So f at 0, straightforward again. I just plug in 0 for this. So I use f at 0 now because it just said y. Before I use h at 0 because they told me h at something. So 0, 0, I'm only left with minus 1. Okay. Now I have 0.15x squared plus 0.3 minus 1. Those numbers look very difficult for me to factor, so I'm not even going to try. Just going to plug it into quadratic formula. Notice that I have a minus and a minus, which will give me a plus, so that's why this ends up being 0.69 and not a negative number. And when I plug into my calculator, doing a plus and a minus, I'm going to get with negative 3.77 and positive 1.77. So if we sketch this, I'm going to get a different one to sketch this. We're going to have that the y-intercept is minus 1 and the 0 is negative 3.77. And the other one is 1.77. And you don't need to be super exact, but the more accurate you can be with your diagram, the more you will know if it makes sense or not when your numbers work out. Because sometimes we work out the numbers, and I'm sure you've never made mistakes, but I've made mistakes when I plug in my numbers. So then for the vertex, I'm going to choose to complete this square. So I'm going to take the 0.15 out, I'm going to factor it out, 0.15, and that leaves me with x squared. 0.3 divided by 0.5 is actually just 2, so make things a lot easier. 2x, half of 2 is 1, 1 squared is 1, so I just add 1, subtract 1. And then when 1 comes out, it gets multiplied by 0.115, and I still have the minus 1 from before, which means that these three numbers will become x plus 1 squared, and the minus 1 times 0.15 became negative 0.15, and with this minus 1, it just becomes negative 1.15, giving us a vertex of minus 1 and 1.15. The only thing that we're left to state the axis of symmetry, which we know is just the x of the vertex, so then that's x is equal to -1. That's the axis of symmetry. And then we go back to our sketch to see if it matches. So it said that, I'm going to just flip it over, the axis of symmetry was -1. Does that make sense? Well, it has to be in between these two, so yes. And then if we graph this, it'd be something like this. And it was 1.15, so it's -1.15. See? I thought it was on purpose, but I made that mistake. I wrote 1.15 and it should have been -1.15. And I realized that when I went this way that it should have been below -1, not 1.15, so I made that mistake. And I was able to fix it. So the vertex should go a little lower. And that's the vertex that you see here, -1 and -1.15. So that was all, everything kind of put together for all the quadratics.